Hi, in this video, I'm going to talk about the molar mass and percent composition. So molar mass is actually the atomic weight or atomic mass on the periodic table, the one with the 2 decimal places number. So we want to find out how heavy it is for each compound. And then percent composition will be like find the percentage of each element, like what's the percentage of carbon, percentage of element, percentage of hydrogen, or percentage of like hydrogen for each compound. So we first want to calculate the molar mass of the compound by adding all the atomic mass together. And that number is actually, you can calculate for each one. You got to add this number, how many of them, add them together. And you give me the answer will be 2 decimal places. And the unit is gram per mole. And gram per mole is the unit for molar mass. And mole, M-O-L-E, is actually just like another unit for like a dozen or pair, or like a decade, just like a unit. And then you also want to give me the chemical formula. So I will show you how to get that. And then the part B will be calculate the percentage composition of the compound by each element. The percent composition is you take the molar mass of each element, divide the molar mass of the total compound times 100%, and you will get 2 decimal places after root rounding. And make sure that you don't use 100% to minus what you know to get the unknown, because what if your first answer is wrong, then the other will be also wrong. So you get it so individually. I'm going to show you how to do that. And then finally, you need to show me the total percentage of the percent composition of the element. It should be 100.00%, not 99.99, not 100.01. It must be exactly 100.00. And you also don't want to write 100, but 100.00, because the percent composition in the chemistry is 2 decimal places. If you write 100%, it's actually not 100.00%. And I'm going to show you how to do that. So this video show you how to do this part. I'm going to show you that step by step from here. So first, we want to find the molar mass of the given formula, NH4 parentheses 3PO4. So we first want to write down how many elements for each, okay? So from this formula, when you see the subscript outside, you're going to try, just like when you do the coefficient, you multiply all the subscript to inside. So you're actually going to multiply this number, you're going to multiply this number, everything inside to get a total. So here I got 1 times 3, which is 3n. So I'm going to write down 3n, parentheses, okay, 3 parentheses n. And I will also have 4 times 3, which is 12h. So 12 times h. And then I have 1p, so 1 parentheses p. And then I have 4o, so 4 parentheses o. So this is what I got. And then I'm going to start to write down the 3 times. So n, if you look up the periodic table, is 14.01, and then O is 6.00. So make sure that all the numbers that you get is 2 decimal places. So 14.01. And the H is 12 times 1.01. And P is 1 times 30.97. And O is 4 times 16.00. Now, make sure that you write down 2 decimal places. Don't put down 16. As I told you here, don't write down 60. That's wrong for molar mass. Okay, so you multiply them. So 3 times 14.01 is 42.03. 12 times 1.01 is 12.12. 1 times 30.97 is 30.97. And 4 times 16.00 is 60.00. Okay, then after that, you're going to add that up all together. Add them all together, you should have give me 3 answers, like 3 parts of the answer. The first thing is 149.12. After you add it all together, 149.12. And then second is the unit. I told you the unit is gram per mole. So gram per mole. And then the third part of the answer is the formula. So parentheses NH4 close 3PO4. So this is the complete answer for part A. Make sure you give me the formula, because on the next class, I'm going to use this concept to cancel the unit. Okay, so if you're missing this, when we go to chemical equation, you have different formula of that. You're going to mess up like which one go to the top, which one go to the bottom. So that's the part A. And then part B, we come to the red area, you gotta find a percentage. You gotta take the molar mass of each element divided by the compound and then times 100 and run it to two places. So I give you reference answer, but they all like not in the order. So I'm gonna show you how to do that. So we know that we have 4 elements. So I'm gonna write down percent of N, percent of H, percent of P, and then percent of O, okay? So my percent of N, I already calculated from here, okay? So will be 42.03 divided by my total, which is 149.12, and then I'm gonna times 100%. And then I will end up with a 28.18535.408%. So on your calculator, all you need to do is just like 42.03 divided by 149.12 times 100 equal. You don't need to put the percentage because it's already have the percentage here. So 42.3 divided by 149.12 times 100. And then you will get this number. And you're going to round it to two places. So it will be 28.1, actually it should be 28.19%. Should be 1.9%. I'll probably have to take a typo on here. But it should be two places. Okay, and then I put N here. So that's my one answer. And then percentage of the H, the same thing. 12.12, which is from here, divided by 149.12 times 100%. And I should get 8.1276, 82408%. And then after I round it, I get 8.13% H. Okay. And then the next thing is percent of the B. So will be 39.97 divided by 149.12 times 100%. And I should get 20.7685085.8%. And then after I round it, it should be 20.77% P. Okay, and then finally, the percentage of the oxygen, 64.00 divided by 194.49.12, and then times 100%, and I should get 42.91845.494%, and after that round it, I should get 42.92% O. That's the red part. And then finally, we're going to show that the sum is 100%. Okay, so right here, make sure that you include the unit, make sure you include the formula. So how do I find out the percentage? I add up to 100. I add this about charge together. 28.1. I probably did something wrong on here. I have to go back to check, but I get 28.18% N plus 8.13% H plus 20.77% P plus 42.92% O. If you add up together in your calculator, you should get 100.00%. If you don't, then you did something wrong. So I need to go back to check if I did something wrong on here. But if you get not exactly 100%, you did something wrong. So this is for the molar mass and the percentage composition.